Hi, this is Mrs. Wiederholt, and welcome to my lesson video on properties of logarithmic functions. Now let's get started. In this lesson, we are going to learn about three properties, and the first one is the product property. And basically, it says the log of a product is the sum of the logs of its factors. Now basically what that means is if you have the log of a number, let's just say the log of 12. Well, can't 12 be broken into two factors like 3 times 4? So if you have the log of a product, you can basically change that to the log of the sums of the factors. So that would be the log of 3 and then plus the log of 4. Now this can work in reverse also. If you have the log of one number plus the log of another number, now keep in mind the bases have to be the same, but then you can multiply these two numbers and simplify this expression right here. Now let's look at the first example. Our first example is log base 3 of 4 plus log base 3 of 7. Since we are adding two logs with like bases, we will multiply their arguments. So this would be the same thing as saying log base 3 of 4 times 7. And 4 times 7 is 28, so that would be the same thing as saying log base 3 of 28. Now, if we had started out with the log base 3 of 28, you would look at 28 and say, what are two factors of 28? Well, 4 times 7. So you could rewrite log base 3 of 28 as log base 3 of 4 plus log base 3 of 7. Now, the reason why I'm doing this all on one side of the equation is because really, see, this property that we're learning, this property is saying if you see it one way, it can actually be written this way, or vice versa. If you see it this way, it can be written like this. And in our example 2, we're going to put this property into use with a real log equation. So let's look at that one now. Okay, so on the left side of the equation, I have log base 6 of x plus log base 6 of 8. Well, I have like logs with like bases, so that means I can multiply these two arguments. So it will look like this. I will have log base 6 of x times 8. And yes, you can write that as 8x. I'm just showing it in the order that they are on the left side. Now remember, that's equal to log of base 6 of 56. Log base 6 of 56. Now let's go back to exponential equations for just a moment. The two rules we learned there that said if you have two bases equal to each other, that means the exponents are equal. Therefore, if the bases are equal to each other, you just set the exponents equal to each other, and you could solve for x. And then likewise, if the exponents are the same on each side of the equation, then you can set the bases equal to each other, and you could solve for x. Well, the same type of rule applies with log functions. If your logs are the same on both sides of the equation, you can set their arguments equal to each other and solve for x. So let's do that. Because I have log base 6 on both sides of the equation, I can take the argument, and this time I am going to write it as 8x equal to the argument on the right side, which is 56. And now I'm just going to solve for x by dividing both sides by 8, and so x equals 7. Now let's look at another property. Okay, the second property we're going to look at is the quotient property. And it says the log of a quotient is the difference of the logs of the numerator and the denominator. So what that means is if you have the log of a fraction, we could say 3 halves. So if you had the log of 3 halves, that simply means you're going to take the log of the numerator and subtract the log of the denominator. This property works in reverse also. If you had the log of 3 minus the log of 2, you could rewrite that as the log of 3 over 2, or 3 divided by 2. Now let's look at the first example. We have log base 3 of 20 minus log base 3 of 5. Well, since we have the difference of these two logs, I can rewrite that as log base 3 of 20 divided by 5. And yes, you could go ahead and simplify that to be log base 3 of 4. Now, if we started out though with log base 3 of 20 divided by 5, we could rewrite that as log base 3 of 20 minus log base 3 of 5. Again, I'm showing these to you all on the left side of the equation because we're using this property to actually solve for a variable like in example 2. So let's look at that example. Okay, we have log base 8 of 24 minus log base 8 of w equals log base 8 of 4. Now on the left side of the equation, I have like bases and I'm finding the difference of them. So I can rewrite that as log base 8 of 24 divided by w. And if you want to put that in parentheses, you can. And that is equal to log base 8 of 4. Now, like I told you in the example 2 of the product property, because I have like bases on each side of the equation, I can set the arguments equal to each other. So I have 24 divided by w equals 4. And so basically this is going to be just a 1 or 2 step equation here. I can multiply both sides by w so that it cancels out of my denominator. And so now I have 24 equals 4w. Divide each side by 4 and w equals 6. Now let's look at our third property. The third power is the power property. And it basically says the log of a power is the product of the log and the exponent. Now what this means is if you have an argument raised to a power, then you can rewrite that as the exponent, which this would be the p right there, times the log. That's what product is. You're multiplying two things. So we're saying the exponent times the log. Now they don't put a parentheses like we might normally see, but it means the same thing. This is the exponent times the log. Now let's look at example 1. We have log base 4 of 6 squared. Now we can rewrite that. We take the exponent 2 and put it in front of the log. And now we're going to write log base 4 of 6, where we are multiplying the exponent, which is 2, times the log base 4 of 6. Now let's look at how we can apply this property to example 2, where we need to solve for x. We have log base 10 of 36 is equal to 2 times log base 10 of x. Even though the log on the left side of the equation and the log on the right side of the equation have base 10, they are not considered like logs because the log on the right side of the equation is being multiplied by 2. And so that makes it different than this one. So if we want to set our arguments equal to each other so that we can solve for x, we first have to apply this power property so that we could have like logs on each side of the equation. So on the left side of the equation, we still have log base 10 of 36. Now using our power property, we know that this 2 right here is actually the exponent of our argument. So we can rewrite the log on the right side of the equation as log base 10 of x to the second power. Now we have like logs on each side of the equation. Both of them are log base 10. And because of that, I now can set my arguments equal to each other. So I have 36 equals x squared. And we know that if we want to isolate x, we need to undo the square, which means take the square root of it. And if we do that on the right side, we have to do it on the left side, so we know that x equals 6. So you have just learned about the 3 properties of logarithmic functions, and if you need to rewatch any portion of this video, please do that, and I look forward to working with you again. Bye-bye.